the quiz that is still open. The other one is open until tomorrow at 10:30. Okay, so if you have not done the other one yet, you still have about close to a day to work on it. Okay, so this is the second one. At this point, this one still does not have a due date, so there's no closing date for this quiz. You can still do it as many times as you want and take as long as it takes for each attempt. But if you cannot work on it, if you cannot understand what the question is asking, or you just cannot get the answer, then it's time to get some additional instruction. So for this one, the question is asking, what is the value of x after this entire expression evaluates? Okay, not just one part of it, but the entire thing. So what you need to do first is to find out the order of operation. In other words, what are we doing first, and then what else do we do to it? Okay. So the first thing, so the parentheses pretty much tells you, how to group the operations. So the first thing you need to do is to perform this particular operation, find out what it does, what does it do to x, and what value does it come back, for the second operation, for the second compound assignment operation. So you have to look at two things. One is the psi effect on x, and the other one is the value of the expression itself. Okay. So, any questions about this one? Go ahead.
Well, I keep going through this, and I understand what you're saying about that, but I keep getting things wrong, and I just don't understand why.
Okay, so for this one, what do you think would be the answer?
What do I think would be the answer?
Yeah.
85.
85. Okay. So, if you're thinking it's 85, you are missing one. Okay, so the question is, why are you missing that one? Okay, when you look at x plus equal to, it is basically saying x equals to x plus whatever the other side is.
Okay.
Right? And it's using the value of x at that time to perform the calculation. So that is the other thing that you have to keep in mind is you don't try to come up with the value of x until you have to do it. So you don't say, okay, I take a snapshot at the beginning, x had was starting off with this number, and I will keep that number throughout the calculation. You basically have to refer to x whenever you need to, and then use the value of x at that point for the calculation.
Okay, so the first order operations in the parentheses, that changes the value of x once
Right.
that's completed. Well, in this case,
That is correct.
okay.
Yeah.
All right.
Okay.
I understand that.
Yeah. So it's almost like you break it up into two different expressions. So if you break it up into two, then it's obvious, where you're missing that one.
Okay.
Okay. So next question. Okay, this one. Any questions about this one? It's basically just if then else. You have a condition to evaluate. This is the true value, and this is the false value. Okay. Next one up. This one. Any questions about this one?
No idea how to go through it.
Okay. So when you guys turn ahead and go like, wow, great, no questions. Okay, that's okay. And once again, the first part is to figure out the order of operation. Okay, the order of operation is key to understanding this particular one. So the first thing is we know x is 63 in this case. So in your question, x is probably something else. So the first thing you need to do is to say, okay, eventually we have to do a bitwise NOT. So that means you need to look at the binary representation of 63. I'm not going to tell you what 63 is, in binary representation. That's for you to find out. I mean, there are easy ways to find out. The Windows calculator can do base conversion. So it's super easy to find out what it looks like in base 2. So once you find out what it is like in base 2, you will realize that 63 does not require even 8 bits to represent. Okay, it only requires like 6 bits to represent. But that's okay, because if you need to make that value into, let's say, a 64-bit number, what do? You only require 6 bits, but you want to turn it into a 64-bit representation. Well, you just pad zeros on the left-hand side until it fills up 64 bits. Because padding zeros on the significant side doesn't change the value at all. So you can now come up with a representation in 32-bit, 64-bit, 8-bit, 16-bit, and so on. No? Okay, so, all right. If I give you a question like, okay, 261 in decimal, okay, but I want to represent 261 in decimal, but using 5 digits, 5 decimal digits, so forget about base 2 for now. 5 decimal digits to represent 261. How would you write 261 using 5 digits? Use all of them. 00261, right? If I want it to be a 10-digit decimal number, what do? Pad more zeros. So in this case, you have to pad zeros until it is the right width in order to perform the negation, the bitwise not on the outside. Okay. So the question is, how many zeros do you need to pad, and what bitwise not is going to do to that representation? Okay. You're smiling because you had that question earlier.
Yeah,
Yes.
And I talked with Danny, and he said exactly. I'm like, oh.
Yes. All right. So question number 4 is really just seeing whether you understand what the comma means in this case. So a comma is really just a separator in this case. It separates the sub expressions from a comma separated expression, but only the last one gives you the value of the overall expression. So what that means is, in this particular case, you have to evaluate this expression in the order from left to right. So this is the first one, this is the second one, and this is the last one. But the value of the last expression becomes the value of the entire expression. So the question really is just asking what is the value of the last expression. Next one, the last one. This one you have to convert it into a base 2 representation first, and then you perform the exclusive OR operation on the base 2 operation. And then you have to convert it back into base 10 for the answer, because the answer did not ask for base 2 representation, so it has to be in base 10.
That's where I got that one.
Oh, okay. Okay. Yep.
Can you go over the exclusive OR operation one time?
I will not go over that. However, I will tell you where to find it. And then based on what I have on the website, you can ask questions, specific questions about that. So if I'm not clear about something, I did not write it clearly, you can ask questions about that, but you really kind of have to kind of refer to it first, and then all questions will be based on that. So exclusive OR is here, bitwise exclusive OR, that would be the table. Yes?
I'm not sure really to talk about this, but I don't really understand the difference between OR and exclusive OR.
There's only one difference. The last row is different. With exclusive OR, if you just observe the last row, I'm not sure whether they will fit on the same page. No, they don't. But if you look at this row here, 1 exclusive OR 1 is a 0. 1 regular OR 1 is a 1. Exclusive OR is basically saying either 1, okay, or exactly 1. Whereas OR is saying 1 or the other or both. But if you just look at the table, that tells you, if the input is a 1, if one input is a 1, the other input is a 1, the output is a 0 for exclusive OR. All right? Is that okay?
Yeah.
Okay. So any particular question about this slide here? I mean, if I am missing something in the description, this would be a good time to ask me and say, okay, there seems to be a gap between these two concepts, and I need a bridge, between those concepts. Anything here? No. Okay. So if there are no questions, then we are moving on to statements. So we are now finally ready to talk about statements. So you might think, oh, finally, we have something that is actually useful. Well, expressions in C and C++ are actually exceptionally powerful already. Okay, this is something that I did with the morning class, so I want to do it with this class as well, is to show you what you can already do with just expressions, without conditional statements, without loops and all the other fancy stuff in a normal programming language. So what I'll do is I'm going to switch to a terminal, and I'll just go ahead and write a program for Factorial. I did it already in the morning, but I'm not going to just use that program. I'm going to start with a new program here. So I will go ahead and write Factorial as a subroutine. Okay, and I'll kind of explain the syntax a little bit here. There's no need to worry about the syntax of a subroutine just yet at this point, because we will talk about subroutines, parameters, and stuff like that later on. So instead of focusing on the syntax, or where do I put an int and where do I put the parentheses and so on and so forth, focus on the concept. Okay, so this is what we call the template of a subroutine that returns a value. The first int on the first line, which is this portion here, it is indicating the type of the return value. In this case, Factorial is a subroutine that returns a value. Is that concept okay with you guys? That you can have subroutines or procedures or functions depending on the language it's called differently that can return a value. And that value in return can be used in any context that an integer is expected. You can use it for comparison, you can use it for multiplication, and so on. So the concept of returning a value is okay? Okay. So in this case, Factorial returns an integer. This is the parameter of Factorial. In my class, I use pseudocode, so it looks different. This is basically the same thing as by val x. Okay, we are passing a parameter x by value. Okay, and I'm hoping in the other classes, cisp301 or 370, they also kind of touch on parameters and subroutines. Okay, basically x is an input into this particular subroutine, and say, okay, I want to find the factorial of this number x. Okay, all right. And inside I will have only one single statement, which is a return statement. A return statement is doing two things. The first thing is, okay, I'm done here. Okay, this subroutine is done. That's the first meaning of return in C and C++. But the second thing it does in this case, because the subroutine is supposed to return the value, I'm also using it to specify what value am I returning. Okay, so in my cisp300 class, it's the same meaning as the return in that class. Okay, it specifies a return value. Okay, so now is a good time to talk about Factorial, just a little bit superficially. So let me just kind of clear away this part here, and then we'll take a look at Factorial. Factorial in mathematics is an exclamation point, not to be confused with the negation, logical not of this class. Okay, so in mathematics, 5 exclamation point means the factorial of 5. The factorial of 5 is easy. 5 times 4 times 3 times 2 times 1. That's 5 factorial. Are there any questions about the math function called factorial? If there are no questions, then we'll go ahead and say, oh, but that really is the same as 5 times, and then 4 times 3 times 2 times 1. I'm just regrouping the multiplication operations, which is perfectly okay, because multiplication is commutative. Now, I should say it's associative, so it doesn't matter which one you perform first, it still comes up with the right answer. But if you think about it, 4 times 3 times 2 times 1 is also known as 4 factorial. So by the very definition of factorial, it is quote-unquote recursive. In other words, the larger number, the factorial of a larger number can be expressed as a multiplication of the number itself and the factorial of the number that is 1 less than what it is. Now you can only keep doing this after a while you get down to 1 or 0. So in that case, by definition, 0 factorial is 1, which also means that 1 factorial is also 1, because if 0 factorial is 1, then 1 factorial is 1 times 0 factorial, which is 1 times 1, and that gives you just 1. Okay? Okay. So knowing this is factorial, we come back here and say, well, can we do this without loops? And you go like this, right? looks like we need some kind of a loop here. We have to go from 5 to 4 to 3, at least to 2, if not 1, in order to compute the product. Well, I can use the recursive definition and say, well, we don't really need it. So what I'll do is I'll use a ternary operator in this case. In other words, I'm going to compare x first. If x is less than or equal to 1, then the answer is just 1. In other words, if x is 0 or 1, then 0 factorial is just 1, and 1 factorial is just 1. So that handles what we call the base case, okay, where we stop the recursion. What if x is greater than 1? What if x is 2, 3, 4, 5, and so on? Well, in that case, I'm going to use the recursive definition. And I will say the factorial of this number is x times the factorial of x minus 1. Like that. So now I have factorial implemented in a single line as a single expression, but inside the context of a subroutine, a function. All right? No conditional statements, no loops whatsoever, just a subroutine, a return statement, and a ternary operator. All right, well, let's see whether that works or not. So this is also what I did in the morning. In the morning class, I use a local variable x to store the result of the factorial of something. 4 would be a good number. It's not exactly trivial, and at the same time, it's not going to be very time-consuming. And I just return a 0 at the end of the program. From the morning class, there was an interesting question. The question was, can you teach me how to print something to the screen so I can debug the program without using GDB? Okay, that was a question. And can anyone in this class, especially if you have taken classes from me already, guess what my answer was to that question?
Yes,
The answer was no. That was the whole idea. You are supposed to use GDB to debug your program, not to print something to the screen. That was exactly how I answered that question. Well, I mean, I understand, some people have the habit of using, printing, dumping something to the screen to help visualize what the program is doing. But that approach can only work up to a certain point. Only up to a certain type of complexity, it is quote-unquote doable, but it's not really the best way to debug a program. The best way to debug a program is to use a debugger, okay, like GDB, or if you use CodeBlocks, it has a similar feature because it's just GDB running in the background, and then use a GUI on top so that you can click, right-click, and do all the other simple stuff in not having to remember all the commands. So okay, so we'll go ahead and take a look at this program using GDB, because otherwise the program doesn't do a single thing. It doesn't give you a value. There's nothing that is printed whatsoever. So this program is only, it only makes sense to use GDB to see whether this program works or not. So we'll go ahead and use a G++ here. And also in the morning class, I told everyone to turn on every single possible warning so that, if the compiler catches anything, you won't have a problem with it. So we'll turn on all the warnings, and we'll also turn on a flag called pedantic, okay, which is very tedious. It gives you like a whole lot of warning messages, not error, but warning messages, if you deviate away from the ISO C or C++ standard. Okay, and then we can supply the -G option to specify include debug information, so I can use GDB to debug this program. And then finally, we can specify the name of the output file and also the name of the input file, which is the source file. And now it's complaining. Now, this is really cool, don't you think? It's a warning, okay, which means if you choose to ignore it, you can do that, okay? A warning is simply the compiler saying, I noticed something is kind of strange here. It doesn't seem to make a lot of sense to me. But as far as the syntax is concerned, it is still okay. So if you still want to run this program this way, go ahead. But I'm noticing that something is strange about this program. So what it is noticing is in the main subroutine, I initialize x. I put a value into the variable x, but then I never refer to it again. Okay, it seems kind of pointless. Okay, that's what the compiler is complaining. Okay, it's not an error, it is just a warning. So you're perfectly okay to do something like this, but it's noticing that I'm using a variable seemingly for nothing. Okay. All right. So at this point, I do have an executable. At fact2, this is the executable of this particular program, and I'm going to use GDB to debug the program. Okay, GDB. I will use list L to list the program, and I'm going to put some breakpoints into this program just so that I have places where I can inspect stuff. So the first one I'm going to put is onto line 3, and then the second one is on line 11. Line 11 is the return statement right after line 10. So I want to examine the value of x in main just to make sure that it in fact is 4 times 3 times 2, which is 24. Okay. Now let's go ahead and run the program. So when I run the program, naturally it will get to the subroutine, and because the subroutine only has one line, which is line 3, it stops on that line. Okay, it makes perfect sense. So I want to print out what is the value of parameter x. The first one is 4. Does it make sense to you? After all, in main, I'm asking the question, what is the factorial of 4? And so it makes sense. But because here, when 4 is 4 less than or equal to 1? No. So that means I have to return the else expression. And the else expression says, oh, okay, we need to find out what is the factorial of 4 minus 1. 4 minus 1 is 3. So if I continue execution, it will call the subroutine again, but this time x has a value of 3. Okay, double check, it does. Okay, I continue one more time, x has a value of 2, and if I continue one more time, x has a value of 1. Now when x has a value of 1, 1 is less than or equal to 1, which means I don't need to do any more recursion. Okay, I'm not going to call factorial again. I can just return a value of 1. Okay, but at this point it is interesting because I only have one subroutine called factorial, but now I have 4 concurrent invocations of the same subroutine. Every time I invoke a subroutine, I'm creating a new invocation. Every time I return from a subroutine, I'm removing one invocation. In other words, the definition of a subroutine is quote-unquote static. Okay, it's just something that you can see on paper. You can see, oh, in the source code, I have one subroutine called factorial. But the word invocation is dynamic. It refers to how many times the subroutine has been called. Okay, and each time it is called before it returns is called one invocation. So right now I have 4 invocations of the factorial subroutine. Now, if you took cisp360 from me, you have been doing traces of subroutine invocation and returning, and that's why you already have an understanding of what an invocation looks like in a trace. But in GDB, there's another way to visualize it. Okay, it's a command called backtrace. Backtrace is just BT. Can you abbreviate it to BT? And what BT does is something that is really, really helpful, especially for complex programs. What it's saying is, right now, at this point, I am on line 3 in factorial. Okay, I know that, it's no big deal. But how did I get here? That's the question. Who called factorial so I am in factorial right now? So if you drop down to the next level, don't worry about these kind of complex, long numbers in hexadecimal, but focus on this part here. I got here because factorial was called from factorial on line 3, and when it was called last time, x had a value of 2. And how did I get there? Well, get down one more line. It got there because factorial called factorial on line 3, but the caller had x equal to 3. And then how did I get there? From another factorial, but x was 4 in that invocation. And how did I get there? Finally, we trace everything down to main and say, oh, main started everything. Okay, main started factorial, but then factorial called itself. Basically, it's called 4 times in this case. Yep.
I don't know if I'm not supposed to be saying this right now, but those numbers in the beginning are the memory locations, right?
It's actually the location where the call happened.
And so if each call is an instance, shouldn't those numbers change? Because shouldn't it be like a
No,
different?
it's being called from the same place.
Oh, okay.
If you look at a function, it is more like a procedure of doing something. It's completely static. It's like operation manual. Okay, so it tells you step 1 do blah, step 2 do blah, step 3 do blah, and the instances are more like the little notes that you have jot down. You have to jot down in order to perform the steps. So in one of the steps, it might say, "Oh, go back to page 1, but start with a new stack of paper," because this is quote unquote a new instance of doing that something. Okay, so you end up with a small stack of paper, and then it gets bigger and bigger and bigger, right? So as the last step of the instruction, it will say, okay, you're done with this particular case. So you take the top stack of paper out and say, okay, I'm done with the first one, and then you return back to the previous one. So that's the way it works.
Okay. And then and on the computer side, that doesn't necessarily relate to different memory addresses. It's still in the same area.
Because this number, the number that I have highlighted, refers to a page number in the manual, in the operation manual, and not the worksheet that you have to use when you're working on it. So that's why it is static, because it is still the page number. The page number is the same, even though your pile of paper, your worksheet, is getting bigger. You're getting a larger stack as you do the recursion. Okay. All right. But the big question is, does it really do what it is supposed to do? So one more continue, and it will complete. It will start to return. It will pop back up down, like from the last factorial, go back to the previous one, do the multiplication, go back to the previous one, do another multiplication, and so on. So if I do one single continue, it will end up on line 11. And at this point, the x of main has a value, which is supposed to be the factorial of 4. So I'm going to print it out. And in fact, it is the factorial of 4. Okay. So let me get out of GDB first and go back into the program, and basically say, I don't have any conditional statement. I don't have any loops, and yet I have the effect of having a loop or conditional statements, depending on how you want to look at it. So this is why I wanted. This is what I want to say is the expressions in C and C++ is actually pretty powerful. Okay, it can do more than what you would expect from just expressions, especially when you come from, let's say, Visual Basic or some of the other programming languages where you can only do so much with expressions. In C, expressions are very, very powerful. Okay. And then the next question that someone is going to have is, are you insane, doing everything like this without using for loops or conditional statements and whatnot? Well, I'm not the only one. So that's both the upside and the downside of that, is I'm not the only one. There are programming languages out there that has no loops and no conditional statements. Okay, one is called Lisp, and the other one is called Prolog. They're very specialized in the programming languages. You can emulate the effect of loops, but they do not actually use loops. Okay, instead they use recursion and this type of ternary operation to simulate the effect of conditional statements and loops. How many people feel somewhat comfortable with recursion, like a subroutine calling itself? Okay, a few. I can identify people who took my cisp360, so I'm expecting those people to say, yes, I feel completely comfortable with recursion. All right, so that's okay for the time being. The first few slides in control structures is basically a repetition of stuff that we have talked about already. So I'm just gonna go through that pretty quickly. If you have questions, go ahead and ask. But I don't think there's anything really new that we haven't seen before. So this slide basically talks about conditions in general in C and C++. Yes. Row sheet. And I got a new one for today. Go. Okay. So the first thing we want to talk about in terms of condition is comparison, because that really is the most used expression that gives you a true-false value as a condition. So there's really not a whole lot to talk about. We have less than or equal to, greater than or equal to, and not equal to. Stuff that we have, we have talked about and well understood already. So now the question is, what if you have a typo? What if when you're typing in or entering a program, instead of using exclamation point equal to, you use vertical bar followed by equal to? Well, they look not too different. I mean, if you think about it, okay, depending on the font that you use. So if I want to say, let's check whether x is not equal to k or not. Okay, let's make it a constant 10. Okay, so this is a legitimate comparison operation. All it is asking is x different from 10? Is it true or is it false? Okay, true is non-zero, false is 0. That's all it's asking. Okay, makes sense, right? And when you look at this expression, not knowing the rest of the program, is it even possible that this expression can return false? That x is exactly 10, therefore the question of whether x is different from 10 can be false. Can it be false? Not knowing the structure of the program. Yeah, x can be 10. I mean, there's nothing that tells you that x cannot be 10, right? And as a result, x can be 10, and when x has a value of 10, x is different from 10 becomes false. So there is definitely a chance that this expression can be false. Okay. Now, if you look at an expression that looks kind of like that, but it's not the same, then you have then I'm asking you, what is this doing, and what if your program has a typo? What if you use the vertical bar instead of the exclamation point when you're constructing this comparison operator? That's the question. All right. The vertical bar may look completely different from the exclamation point using this particular font, but if you use a different font, sometimes the vertical bar looks like this. Okay, it looks like 2 line segments with a break in between. So it is possible that someone who's starting out programming in C and C++ may mistake, oh, okay, not equal to is using the vertical bar instead of the exclamation point. That is possible. But the question is, what would happen? Well, first of all, is this, the highlighted portion here, is that even a valid operator? Will the compiler complain and say, this is not something that I understand, and it stops right there? It is something that is a valid operator. Okay, what type of operator are we dealing with here? It's a compound assignment operator, and to be more specific, what is the operation that we are doing? Bitwise OR. Okay, so we have a bitwise OR compound assignment operator. Okay, what does it do?
It's going to return back.
Now, a OR operator, a bitwise OR operator, go ahead.
It would take the x value, in base 2, and the 10 value in base 2, and it will perform the OR table.
Yep, exactly. Okay, and then bitwise OR is useful for turning on a bit, right? Making sure a bit is 1 as a result. Okay, so what this will do, okay, first of all, let me re-express 10 as a power of 2 or a sum of powers of 2. So it becomes 2 to the power of 1, basically just 2, plus 2 to the power of 3, which is 8, right? 2 plus 8 is 10. Okay, so in binary, 10 in decimal is 1 0 in base 2 plus 1 followed by 3 zeros in base 2. Okay, we kind of talked about this in base conversion. Okay, the exponent indicates the number of zeros on the right hand side. Is that okay so far? Yeah. Okay, so that means 10 in decimal in binary is 1 0 1 0 in base 2. And as I said a little bit earlier, you can pad as many zeros as you want on the other side. Doesn't do a single thing. Okay, very good. So a bitwise OR with 10, which is what this one will do, is going to ensure that bit 1 and bit 3 ends up to be 1s. Okay, let me say that again. This is bit 1, this is bit 3. So where's bit 0? That's our bit 0. Okay, we count from 0 because that is indicating how many 2 to the power of zeros do we have. So that's why we're counting from 0 and not 1. Okay, but the result is nonetheless setting certain bits to become 1. Okay, so when you think about it, the OR operation is making sure bit 3 and bit 1 are, they certainly will become 1s as a result. But since this is a compound assignment operator, that also means the result of the bitwise OR is stored in X. There's a side effect to this operator. And not only that, the resulting value in X becomes the result of the entire expression. That's a typical thing of an assignment operator in C and C++. Okay? So now I can say that this expression will do two things that are kind of bad. One is it is always true. Okay? Why do you think I said this statement is always true? Because, go ahead.
Always return back to value.
It will
That
always
not be
return.
zero, since you're using it, always, unless you like, I don't know, even if you order it, regardless of what X is, that's always going to return some value that's greater than 2.
Exactly. If it were an and, then there's a chance that it might give you a 0, but because it is a bitwise OR, bit 1 and bit 3 are guaranteed to be 1s, which means the entire number is guaranteed to be a non-zero. And a number that is non-zero is interpreted as true. So this, as an expression, is always true. That's the first part. That's the first part of it. The second part is it has a side effect. If you look at the original or the intended expression, does this expression change the value of X? Nope. But this one does. So that means after this so-called comparison operation, X is now changed. Okay, X now has bit 1 and bit 3 guaranteed to be turned on after this statement. Yep.
Okay, so let me just make sure I understand this then. So after, for the second one, we're doing the bitwise operator.
Yep.
It wouldn't store the operation that we go through with the table on there. It would bring back a true. Is that what you're saying?
Okay. A compound assignment operator has two things that you have to track. One is what it is doing to the variable. In this case, doing to variable X. And then the second thing it does is it has a return value. The expression itself has a value associated with it. And that turns out to be the same as the value stored in X after the operation.
And is that the one in binary code then?
Binary is just one way to look at it, but yes, it is. It would be the. I can give you an example.
But so, depending on how X is used, though, if you meant to put in the comparison here, wouldn't that crash your program? Depending on how you're using
No, it
X?
does not.
It wouldn't.
It would not.
Okay.
It would crash possibly later on, because the value of X is no longer what it was before, because I have changed it. So the rest of the program may crash because of that as a result. But it's not going to crash here. It would just do the wrong thing, but not crash it. Okay? So that means if someone mistakenly used vertical bar equal instead of exclamation point equal, even though visually the program looks almost, well, I wouldn't say identical, but it looks similar to the intended code, the behavior of the code will be completely different. Okay, and that's one of those things where in C and C++, you really have to pay attention to the details, because the language was designed to it's designed in a way that making small mistakes like this is not going to crash or have a compile time error. Instead, the program is not going to do what you think it is supposed to do. Okay, which is kind of bad, as a for beginning programmers, because now you have to spend all the time just because you made a simple mistake with the punctuations. The other thing I also want to emphasize at this point is double equal is needed in order to express equal to, because a single equal is just assignment. Okay, so it has, if you mistakenly use a single equal symbol instead of double, it has the same kind of deal where the variable is changed instead of comparing. Okay, and it's also really hard to spot. Fortunately, the compiler catches these things. The compiler would say, you have an assignment here. It doesn't seem to make a lot of sense. So it will force you to use parentheses, extra parentheses, to indicate that yes, this is exactly what I want to do. Are there any questions about comparisons? The other ones are fairly, not so exciting. No questions here? Okay. The rest of this slide is stuff that we have talked about already, how C and C++ really doesn't have a value of true or a value for false. 0 is the same thing as a false value, and non-zero is the same thing as true. So we talked about that quite a few times already. So that's basically here and here. There's nothing really new here. The result of a comparison, like 3 is less than 4 as a comparison operation, is just guaranteed to be non-zero. That's all you know. Okay, you have no idea whether it's 1, -1, 5, 3, 4, or whatever. It's just guaranteed to be a non-zero value. And then we talked about Boolean operators. Double ampersand is logical AND. Double vertical bar is logical OR. And then a single exclamation point is logical NOT. So we talked about all this stuff already. There's nothing new in this particular document. Are there any questions about this document? No questions? Okay. There seems to be like 2 NOT or negation operator here. What if I use the wrong one? What would happen? In other words, if instead of using exclamation point X, which is what I intend to be a logical NOT, what if I use a tilde X, which is bitwise NOT? Well, yep, go ahead.
Again, the second one's going to change the value of X, and the first one.
No. These are not assignment operators.
Oh,
So neither is going to change the value of X. Okay. So each one will only take the value of X and calculate either the logical or NOT or the bitwise NOT of X. Okay. Well, in this case, it depends on the implementation of the compiler. With a particular implementation, they can do quote unquote the same thing. It all depends on how true is represented. Okay, let's say for a compiler, true is always represented with all the ones turned on in the integer. Okay, just imagine. Okay, with a particular compiler, when it wants to represent the value true in a Boolean operation, it always uses 1, 1, 1, 1, 1, 1, 1, 1, all ones, to represent true, and all zeros to represent false. Okay, in that scenario, these two are quote unquote interchangeable. Okay, think about it. Okay, if X is in binary, okay, so in this case, 1, 1, 1, 1 in binary. Okay, not X, which is saying logically knotted, it turns non-zero into 0. So it's just 0, right? The other one is also going to be the 0. Because if you have 1, 1, 1, 1, all ones, then all of those ones will turn into zeros all at once. So the result is going to be all zeros. So in this case, these two are quote unquote the same. But what if true is not represented as 1, 1, 1, 1? Instead, it is represented as 0, 0, 0, 1. So I'm using a 4-bit representation, 4-bit integer here, which does not exist in C and C++. But I don't want to have a whole lot of zeros, in this case. So I'm just kind of limiting myself to 4 binary digits. So if X is 0, 0, 0, 1, and the width of the integer is exactly 4, not X, logical not X, is still a 0, right? Because it turns a non-zero into a 0 into a non-zero. So since I start off with a non-zero, the result is a 0. Is that okay? What about bitwise NOT? It's going to be 1, 1, 1, 0 in base 2. Right? Because it's a bitwise NOT, I flip each and every bit. A 0 turns into a 1 turns into a 0. So bitwise NOT 0, 0, 0, 1 in binary becomes 1, 1, 1, 0 in binary as a 4-bit integer. Are we still doing okay so far with that concept? What that means is something is trouble. Because that means if X is true to begin with, not X, bitwise not X is also true. And the worst part is it depends on the compiler implementation. Okay? Because if your compiler decides, oh, I always want to represent true with all ones in an integer, then this is called masking a problem. Okay? Because of the implementation of a compiler, it is masking the issue that you're using the wrong operator. Okay? The problem does not show up. So you can write an entire program using the wrong operator, not realize that you have been using the wrong operator, until you try to compile the same program using a different compiler that does not make sure that true is all ones. Then the problem will show up. And then whoever wrote that program will be scratching his or her head because this program used to work. I didn't touch the program and now it doesn't work anymore. Okay? That can be a very frustrating experience. Just ask me. No, I did not make this particular mistake, but I did make some other mistakes that are just as annoying, if not more. Okay, so that means when you study operators in C and C++, you really have to know which one is which. Okay, not just approximately. Oh, this is not, and that is also not. Nope, they're not the same thing. Okay, one is a logical not, the other one is a bitwise not. They're not the same thing. Are there any questions about everything that I have talked about here?
How are you getting the logical not 0? You're converting it to base 10, the x?
Nope. This is already in base 2, and this is also in base 2.
I'm talking about above that.
And this one here, 10.
Down.
Huh?
Going down? Down?
This one?
No, below that.
Then you need to scroll.
The exclamation X. No, keep going down.
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 You're going down.
Down, last from the bottom.
It's the second to last from the bottom. Yeah.
This one?
Yeah.
Because this is not logical not. Logical negation means you turn a non-zero value to a 0 value to a non-zero.
Oh, okay. This goes from non-zero to 0.
Yeah, it's logical not. Yep.
So, with the logical not, if you have any number of relevant digits, if it's above 0, it turns into 0?
Yeah. Okay. If you apply the logical not to an expression, it means if the expression is 0, the result is non-zero. Not non-zero is 0. Not 0 is non-zero. Okay, let me go back to the notes here because I do want to point out where to find this stuff just in case anyone wants to go back to that portion. So we talked about this in types of expressions and simple statements, I think. Nope, nope, right here. Yep. So the table of logical not is here. This is the logical not table. So X is basically quote unquote the input. Okay. So if the input is 0, then the logical not is guaranteed to be non-zero. But I have no idea which non-zero value is going to pick. It is compiler dependent, it's runtime dependent. Many factors can change that. If the input is a non-zero, I don't care which non-zero value is specified, but logical not of that is going to be guaranteed to be just simple 0. Yeah, that's how the logical not operator is defined. So these tables are useful because it is a very concise way to tell you what an operator does. And it is also used in many other classes, in your future, to define operators. Yep.
Is there ever any way of indicating true?
You can use 1.
But you say it doesn't have the actual true.
It does not have any word to describe true in C and C++.
But false is going to be 0.
False is just 0. You
So
can always say
false
not.
is not true.
That is correct. Because anything other than 0 is true. Okay, so one way, let me go back to the editor here. Okay, so we know how to represent false, right? False is just 0. So that means true. If you really want to express it symbolically, it's just not false. So that's one way to express true without using the word true or a particular value. You just say it's not false. Am I answering your question? Okay. All right, so let's close this, and then come back to here. Okay, so we talked about this already, how we use an integer value for Boolean expressions. Result of a comparison, we talked about that already. So this entire slide is now done. We basically moved many of these topics already into the expression discussion. So this is just a repetition of all that stuff. So now that we got this done, then we move on to expression statements, okay, which is the simplest kind of statement that you can have in C and C++. Okay, give me an expression, okay, any expression, add a semicolon at the end of it, it becomes now a statement. Now, it can be a useful one if it's an assignment statement or a compound assignment statement expression. Then it becomes a statement that is actually useful. But you can also give me an expression that doesn't do a single thing. Okay, if I put a semicolon next to it, now it becomes a statement. Not useful, but still a statement. So syntactically, that's all you need to do. So if you look at this particular expression, a simple 6, okay, as a digit, it is an expression. It's a constant. It's an expression. If you add a semicolon at the end of it, it becomes 6 semicolon. Now it is a statement. That doesn't do anything. Okay? So, but syntactically, the compiler will take it. It's like, okay, I'll take it. And then they will complain about it and go like, this doesn't seem to do anything useful. So the warning will tell you something about it, but it's okay. Okay, it is syntactically still quote-unquote correct. So I want to show you just quickly what it looks like. So I'm going to use the same program, Factorial 2 here. So I'm going to put exactly the same thing here, 6 and then a semicolon, and then go back and recompile the program. And you can see that now there are 2 messages. The first one corresponds to 6 semicolon, and it is only a warning. It is basically saying this statement has no effect. In other words, it is as if the statement was not even there. It doesn't do a single thing that is useful. And then you might ask and say, well, but who would do something like that? I mean, you'll put an expression that has no effect. Well, what if those times when you're copying and pasting, okay, because there's another assignment statement somewhere else in the program that is really complex and you want to just copy and paste that code, the expression, but you want to store it into a different variable. So you copy and paste the expression on the right-hand side, and then you say, okay, I'm going to specify the variable that will be storing this, and then you get distracted. Okay. And when you come back, you forgot all about it, and now you have an expression sitting all by itself with no assignment operator in it. The compiler will catch it and say, did you forget something here? Okay, so it is useful because it will catch certain things that we do that is kind of questionable, and it will remind you and go like, I'm not sure whether you really want to do this or not because it doesn't seem to be useful at all. All right. Okay, and that's it. Expression statement is really just this much stuff. Okay, so for the most part, when we refer to expression statements, we are referring to something like that. Okay, with some kind of assignment in it. Okay, either a simple assignment or a compound assignment. Those are fairly useful statements. Okay, with a semicolon next to it, becomes a statement. Any questions about this particular slide? Okay, simple. Take any expression, add a semicolon, it becomes a statement. All right, moving on to block and compound statements, which is also very simple. Basically, a block statement starts with an open curly brace and ends with a closed curly brace, and it can nest. Okay, that's all that I can talk about it. A block statement is kind of like a folder. Okay, it is a container. So inside a block statement, you can have any number of other types of other statements. So you can have 0. Okay, you can have open curly brace followed immediately by a closed curly brace, which is an empty block. That's perfectly okay. Syntactically, it just means there's nothing to do. Okay, or you can have nested statements inside. You can have another block inside. You can have conditional statements inside. You can have loops inside. It doesn't matter. Okay, it is just a container. But what it does is it will collect everything that is inside, and from the outside perspective, a block statement is simply a statement. Okay, so this gives you the ability to specify multiple operations when a single statement is expected. Okay, there are many places in C and C++ where a single statement can only go into that place. But what if you have different things to do? What if you have 20 gazillion things that you need to do? Well, use open curly brace, specify the 20 gazillion things that you need to do, close curly brace, and now it is considered as one single block statement, and you're done. Okay, so this is a really useful construct. Other languages like Visual Basic is a little bit different, because Visual Basic, whenever you start a conditional statement, it has an end if to indicate the end of the conditional statement. Okay, so it doesn't need blocks nearly as badly as C and C++. So in the next slide, it will be very clear why we need block statements. So the next topic talks about the conditional statement. So with a conditional statement, there's a link here to the official description of a conditional statement. And this is what it looks like. And I'm going to zoom in so that we can look at the syntax of a conditional statement as described by creference.com, okay, which is a really good, useful resource when you want to learn a particular programming language. Okay. For the most part, I think it is really useful to know how to use resources other than stuff that you can find directly on Moodle. Okay, I'm not saying that, well, I don't want to do this job of teaching you guys stuff. Okay, go somewhere else and learn it by yourself. Okay, you can do that already. You don't have to come to this class. But I do want to show you how to learn, how to get extra resources, because guess what? By the time you graduate from here or from a 4-year university, you'll be learning something completely new. Okay, your first job may use a programming language that you have not been exposed to in your 4 year of undergraduate study. So what do? There are no professors anymore. Well, I mean, you can still come back to and visit me in my office. I welcome you guys to come back all the time. But you can't do it while you're on the job, right? And don't text me, I don't like that. So what do? Well, you have to learn how to use these resources. And the first thing you need to know is to read how syntax is described, okay? Because that is the first thing that you need to do. So in this case, the syntax of a conditional statement starts with the keyword if, okay? It is in boldface. It means it has to be there as spelled like this, okay? IF. And then you also need the open and the close parentheses surrounding the condition. They are also in boldface, which means they are also required. Okay. Anything that is in gray and italic means it is a placeholder. Okay, it's a token, or otherwise known as a placeholder. So condition, it is gray and it is italic, which means it is a placeholder. Replace this part with an actual expression. That's basically what it means. And you can only have one statement to specify what to do if that condition is true. One single statement. It doesn't say statements, right? A single one. The alternative form of a conditional statement is the same for the first part, but after the single statement to represent what to do when the condition is true, you can follow that with an else keyword, and then after that with a statement to specify what to do when the condition is false. Are there any questions about the basic syntax of a conditional statement? I mean, that really is it. Okay, it's not a basic syntax. That is the syntax of a conditional statement. Yep.
In the front of it, the only option there would be an else, right? Like where it
Yes.
says,
Yeah.
There's nothing else that you would add to it.
Yeah, this part is optional, but before the if, there's nothing else you can do. This part here, don't worry about it at this point. It simply means that there are attributes that you can specify on a per statement basis.
Well, yeah, that's what I was asking about.
Yeah, so we are not going to talk about those attributes, not in this class. Okay. So for the time being, ignore attr, the attribute optional part, and just focus on this part here. That's the syntax. But it is also, well, if you just look at the syntax of a conditional statement, it's very limiting because it says you can do one and only one thing for the then statement. Okay? But if you think about the previous slide about block statements, then you realize, oh, I can just put a block statement as a statement underscore true. Then you can stuff any number of stuff inside or nothing. Is that making any sense? Do you see the connection between the previous slide about block statement and this current slide that talks about conditional statements? Now this is very evil. Okay, the way a conditional statement is structured is extremely evil. So what I'll do is I'm gonna go back to my notes here, and this time I'm going to repeat what I used a little bit earlier in the day. And what we'll do is we'll look at this mess here. Okay, this mess is representing something that is syntactically correct, but I want to find out, how it is really structured. According to the indentation, okay, it means, this is an overall conditional statement. If C1 is true, we execute whatever this is, else we execute whatever this is. Now, in the then part of C1, we evaluate C2. If that is true, we do this. If not, we skip over and then we get out of the conditional statement altogether. The else part specifies a if-then statement. If C3 is true, we perform this part here. If C3 is not true, we perform this part here. But that's not what it does. Even though syntactically using indentation, it seems to suggest that's what it's doing, that's not what it's going to do. So what we'll do is I'm going to copy and paste this, and then we'll analyze this code as if we are the compiler. Can anyone kind of guess in my previous occupation what I do for a living? I wrote compilers. So I tend to be able to think like a compiler because, well, unless I can think like a compiler, I cannot write the code for a compiler. Okay, so let's go ahead and take a look at this from the perspective of a compiler. All right, and this is the one part that is really, it shows well when you're watching the YouTube video, but it's really hard to do it without the video because I have to keep highlighting stuff and highlighting some other stuff. Okay, the compiler sees if, okay, and that tells the compiler right away and say, expect the rest of a conditional statement because this has to be the beginning of a conditional statement. Okay, no problem. So at this point, the compiler expects an open parenthesis, finds it, no problem. Finds an expression as the condition, no problem. Finds a closed parenthesis, no problem. So right now, at this point, at the blinky cursor, the compiler is saying, okay, now I'm expecting a single statement as the then statement of this particular condition of C1. Is that making any sense?
Yep.
Okay. So it's expecting one single statement. And it is seeing, oh, I have a conditional statement as the then statement of C1. Not a problem, right? A conditional statement is a statement. And then it continues to parse the rest of it, not a problem. Okay, we find the condition. And now we are into the second or the nested conditional statement using C2, right? So as with the first one, now it's expecting a single statement it's expecting a single then statement corresponding to C2. Is that okay so far? And it's finding x is k1 and then the semicolon. So up to this point, the compiler is saying, oh, okay, I have just found the then statement corresponding to C2. Okay, and the compiler now understands, okay, I am at a point where an else may happen. But that else is corresponding to which condition? Is that else corresponding to C2 or corresponding to C1?
We'd still be in C2.
Exactly, we're still in C2. Okay, so when it finds the else word here, it is saying, oh, okay, so when C2 is false, the following specifies what to do when C2 is false, not when C1 is false. But tag, the indentation clearly indicates this is corresponding to C1 and not C2. C doesn't care. The C and C++ compiler does not care about indentation. You can put this entire program on a single line and the compiler would not care about it. It's like, as long as I got my semicolons, I'm good. Okay? So it is misleading. So now this else is actually corresponding to C2, not C1. And after the else, it's expecting a single statement, right? It finds, oh, okay, there's a conditional statement corresponding to the else of C2. Fine, okay? It parses this portion and expects one statement. Good, found it. Processes the else, expects one statement, and finds it. So this entire conditional statement becomes a part of the else, but that else is corresponding to C2. And now, if I have another else here, this else would correspond to C1. But since I don't have an else here, that means C1 really does not have an else statement. Yep.
So there's, but so C1, technically, does it have a then statement? And
No, it has a then. The entire if C2 blah 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 is the then statement corresponding to C1, but has nothing to do for the false. When C1 is false, there's nothing to do. Okay?
So really, it's like the first instance that we saw on the example here, where it's just like the if the condition statement true, because there's no
Correct.
else part.
Right, because this else is taken up by this if here. Okay. Yep.
So C1 is false.
It moves on to whatever is after this entire block of code. All right. Well, that kind of begs the question: what do we do when we have to specify something like this, with nesting and all kinds of stuff like that? Well, let me show you what I do when I write conditional statements, and this is true. I'm not just saying that it's a good practice. I actually do it. When I write conditional statements, I do this. I type up the entire framework of a conditional statement. Then I go back and say C1, and what do I want to do when C1 is true? I have another conditional statement here. Oops. Okay, and that conditional statement starts with a C2, and the only thing I want to do is to specify the then portion, and specify that as the then portion. There's nothing to do for the else. I leave it there. I don't even bother to delete it, okay? Just in case I need to specify the else later, I already have a place for it, okay? And now I can move on to the else of C1. So else of C1 goes here, and I say, okay, I got another conditional statement here. Do the entire structure first, and then go back and specify, okay, we have condition C3, and then we have x equals to K2 here, and then x equals to K3 here. That is how I would write the code that is seemingly connected to this, but remember, this one doesn't do what it seems like it would do. Okay?
Within the curly brackets of the first then statement, you could get rid of the else?
Yes, I could, but I usually do not, because that gives me a place to put in code in case I need to use it. A lot of times, when you're writing programs, the first time you do something, you kind of try to shortcut something, and so some of the conditions are not quote unquote caught. Okay, I know this is an error condition, but at this point, I just want to focus on what if nothing goes wrong. Okay, so I want to finish that route of thinking first, and then in a second pass of the algorithm, then you want to catch all the problems that can happen and report all the errors. That's when you go to the empty else blocks and say, oh, okay, this is not good, okay? The database failed to be, I failed to connect to the database. I better spill out a message now and say, okay, failed to connect to database, blah, 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 blah. Okay, but at least you have a place to put it instead of, going back in and go, okay, where do I put this else? Okay, is this else corresponding to this if, to this condition? You don't have to think about it. It's already structured right from day one. Now, granted, if I write my program this way, it is quite a bit longer. Okay, you can see this is kind of long. But on the other hand, you cannot make the mistakes that I have been talking about earlier. It's just Not possible, because the framework is here already. There's no way you can confuse, oh, okay, is this statement executing after the conditional statement, or is it a part of the conditional statement? I know we are running out of time, but we still have 1 or 2 minutes left. So that's enough time to go over a simple example, like this one here, okay? So when you first wrote the program originally, you might have up to this much, which is perfectly okay. If x is less than y, we want to make z the same as y. Okay, perfectly okay. And then later on, when you continue to write the program, you might want to say, oh, you know what? I want to count the number of times that x is less than y. So I'm going to use n as a counter and count it when x is less than y. Also bump up the value of n. But guess what? That n equals to n plus 1 is outside of the conditional statement. Because the conditional statement, without using the curly braces or a block statement, will only take the one single statement after the parentheses expression to be the then statement. Whatever is after that has absolutely no connection to the conditional statement at all. So that means in this case, n gets n plus 1 is not a part of the conditional statement. It always executes. And if you use n as a counter, then you'll be counting every single time that you go through this code, and not only the times when x is less than y. This is a very common mistake for people who are starting off, because the indentation seems to be indicating everything is good. The compiler does not complain, because as far as the compiler is concerned, n gets n plus 1 is simply a statement after the conditional statement, as opposed to a part of the conditional statement. But syntactically, it is still correct. It's not wrong. Okay. So are there any questions? Do you guys still want to learn C and C++? But I'm trying to point out all the pitfalls, all the things that can go wrong, and why they can go wrong, as early as possible, so that you guys would not. And when you do fall into one of those traps, because eventually one of us, I would fall into one of these traps occasionally. But when I look at a symptom of the program, I know, okay, this is because of that. Okay, at least I know possible, errors that can lead to problems, and I will be looking for. Okay, did I forget about, open and close curly braces?
So that could be fixed just simply by adding in the brackets, then the curly brackets.
Yeah, this problem can be solved by just putting an open curly brace here and a closed curly brace here. But if you had open and closed curly braces to begin with, then you wouldn't even have the problem to begin with, because you would have the open and closed curly brace even when there's only one thing to do. So inserting one more statement is still inside the curly braces, so you won't have a problem. All right, so we are right on time today, and I'll see you guys next week, next Monday. Have a nice 5 days, and make sure that you review the stuff that we talked about and read ahead of me. Okay, so go ahead and read about loops with this particular topic. And I can shut down the recorder.